Let's look at this little problem. A top is a toy that can be spun and it spins around on a surface. It looks somewhat like an upside-down mushroom. The stem of the top, it has a radius of 0.5 centimeters and the widest part of the hat has a radius of 3 centimeters. To get it to spin, you can wrap a string around the stem and then pull on the string fast. Assuming that you pull the string with a tangential velocity of 5 meters per second, what is the angular velocity of a point on the rim of the hat? So let's write down the stuff that we know. The problem tells us that the radius of the stem, so I'm going to call it r sub s, is 0.5 centimeters. And the widest part of the hat has a radius of 3 centimeters. So r sub hat is 3 centimeters. To get it to spin, you wrap a string around the stem and yank on it with a velocity that's tangential, and that's velocity tangential on the stem is 5 meters per second. And we're looking for the angular velocity of a point on the rim of the hat. So here I made a little drawing. There's the blue string that is attached to the top, and we are given the radius of the stem, so that's the radius of this little thing in here, and the radius of the widest part of the hat part of the mushroom, of the stop. And when we're pulling on it, we're giving it a tangential velocity for the stem at this point. So pulling on this will set the whole top into motion. It will all spin. And we want to know how fast, what angular velocity the widest part of the top will have. So remembering that V tangential is r times omega, and since we know the tangential velocity of the stem and we know the radius of the stem, we can find this omega. So I guess I'll call this V tangential stem is r stem times omega stem. So omega stem is V tangential divided by radius, and that is 5 meters per second divided by 0.5. I have to convert the centimeters into meters, 10 to the negative 2 meters. And when I do the calculation, I end up with 1,000 radians per second. And now I don't want the angular velocity of the stem. I don't want the angular velocity of this portion that's spinning. I want the angular velocity of the hat part. How are those related? Well, since when you have an object, a solid object like this, that is spinning, every single point on it has the same angular velocity. So the angular velocity of the stem and the angular velocity of the widest part and the thinner part, all of those have the same angular velocity. So it turns out that angular velocity of the hat part is equal to the angular velocity of the stem, so that is 1,000 radians per second. So the trick here, I guess, I don't know if it's a trick really, is to picture the image and realize that all points on this top are going to rotate with the same angular velocity. Now, I could have asked for the tangential velocity of the widest part, and that tangential velocity would not have been equal to the tangential velocity that we were given here for the stem, because it's close to the axis of rotation. That's only 0.5 centimeters from the axis of rotation, whereas that point is at 3 centimeters. So it would have a different tangential velocity than the stem has. But the angular velocity, the point of this exercise is to see that the angular velocity of all points on a solid object that's spinning like this is the same.